Hello, this video is about how you can represent like terms and polynomials with food. So the way I've decided to do this is to pick a bunch of different foods and sort of like assign numbers and variables to them. So I'll go through the list of stuff. So the first thing is these nuts. They're going to represent like a 1, and if you put 2 of them together you get 2. If you put 3 of them together you get 3. These marshmallows are going to represent X. These Mentos are going to represent Y. These gummy worms are going to represent Z. These Skittles are going to represent plus. These jelly beans are going to represent minus. These black candies are going to represent exponents. So if you put 2 of them together, you get to the power of 2. If you put 3 of them together, you get to the power of 3, so on. And these little pieces of Twizzler are going to represent those lines and fractions that represent division. So here is an example of a term. This would be 5xy because there's 5 of these nuts and then a marshmallow and a Mento. Marshmallow is X, Mento is Y, and these together are 5. And then you can add a like term to it, such as 3xy. And if you were to add these together, you would get 8xy, because since they're like terms, you can add them together. So here's an example of 2 terms which are not like terms, which means you can't add them together. So this one is 5xy, and this one is just 3x. Now since you don't have xy and just x on this one, you can't add these together. So here's an example of something that isn't a polynomial. So this one is 8y to the power of minus 3. So the reason this isn't a polynomial is because it's got a negative exponent, which is not allowed. So here's another example of something that isn't a polynomial. So this one says minus 2 over x. It doesn't matter if the minus is in front of the 2 over x or if it's minus 2 over x. It doesn't matter. Either way, same thing. This isn't a polynomial and can't be used in polynomials because you can't have a variable as the denominator. Here's a polynomial. It's a trinomial because there's 3 terms. This one means 8x squared plus 3x minus 2. Here's the 8x squared plus 3x minus 2. The degree on this one is 2 because the leading coefficient is 8x squared and the squared is 2, so the degree is 2. Alright, so here's another polynomial. It's not a trinomial or anything, it's just a polynomial because there's more than 3 terms. So this one means x cubed plus 2xz to the power of 4 minus 7x plus 6. So here's the x cubed plus 2xz to the power of 4 minus 7x plus 6. So the degree on this one is 5 because the leading coefficient is this one, because this one, the x, actually is an invisible 1 because you just don't write 1s. And this one is 4, so in total that's 5. So the degree on this one is 5. Alright, here's another example of a polynomial. This one's a trinomial with some like terms in it that can be added together. So this one says 2yz squared plus 3x minus 3yz squared. So there's the 2yz squared plus 3x minus 3yz squared. So the 2yz squared can be added together to create minus yz squared plus 3x. So the reason it's minus yz squared is because you had the 2yz squared minus 3yz squared. So that leaves you with minus 1yz squared. But you don't put the 1 there, it's just invisible. So it's minus yz squared plus 3x. So that's the end of my video about how you can represent like terms and polynomials with food.